In this video, we're going to have a look at the converse of the theorem of Pythagoras. The theorem of Pythagoras says that if you know that a triangle is a right-angled triangle, you can accept that the hypotenuse squared will be the same as the sum of the squares of the two shorter sides. Now we can also swap around this theorem and say that if we know that in any triangle, the longest side squared is equal to the sum of the two shorter sides squares, we can accept that that triangle is then a right-angled triangle and that that longest side is also the hypotenuse. Example 1. Given triangle ABC with AB equal to 12 centimeters, BC 9 centimeters, and AC 15 centimeters. Prove that triangle ABC is a right-angled triangle and name the right angle. Here we are given 3 side lengths, but because we don't know which type of triangle it is, we don't know if there's an hypotenuse. We do, however, know that if there is an hypotenuse, it will be the longest of the 3 sides. So now we can test whether that is the hypotenuse. To do that, we need to test whether the side we think is the hypotenuse squared will be equal to the sum of the squares of the other 2 shorter sides. To determine whether an equation is true, we need to do the left-hand side and right-hand side separately. I'm going to start off with the left-hand side, where I square my longest side of 15, and that will give me 225. And then separate from this, I'm also going to calculate the right-hand side of the equation. This is taking the 2 shorter sides and squaring them and adding them up. This will give me 144 plus 81, and that is also 225. So now I can make the conclusion that the left-hand side, my hypotenuse squared, is equal to the sum of the other 2 sides squares. And that means that triangle ABC is definitely a right-angled triangle. And the reason for this will this time be Converse, Theorem of Pythagoras. Now we are also asked to name the right angle. Now the right angle is always right across from the hypotenuse, and in this case the hypotenuse was side AC, which means the right angle right across from it will be angle B. From the Theorem of Pythagoras, we already know that when working in a right-angled triangle, the hypotenuse squared will always be equal to the sum of the 2 shorter sides squares. But what happens if we now make that angle a bit smaller? If we form an acute angled triangle, you will note that the longest side squared is now smaller than the sum of the 2 shorter side squares, and that is because the original hypotenuse was shortened. And if we go and form an obtuse angled triangle, you will see that the longest side squared is now bigger than the sum of the 2 shorter side squares, because the original hypotenuse has now been lengthened. This means that we can make use of similar calculations than that of the converse theorem of Pythagoras to determine the type of triangle. Let's go and have a look at an example like this. Example 2. Determine whether triangle DEF is a right, acute, or obtuse angled triangle. Even though this triangle looks like an acute triangle, we can't accept that it was drawn to scale, so we need to do some calculations. For this, I'm going to start by identifying the longest side and then take that 10 and square it to get to 100. Next, I'm going to take the 2 shorter sides and also square them and then add them up. 49 plus 81 will give us a value of 130. So now we can say that the longest side squared is smaller than the sum of the two shorter side squares, and therefore this is an acute angled triangle.